Okay, so now we're going to look at density. Think of the density of the classroom. Right now, it's not very dense, right? We have very few people compared to what we normally have, compared to what if we squeezed like your parents plus you all in for an orientation night or curriculum night, we become much more densely packed. Well, density is literally that. It's the measure of how much mass is contained in a given volume. So it's comparing two things, mass and volume. And we see that relationship right here. So two substances can have the same mass but different volumes. A ton of bricks has a lot less volume than a ton of feathers. So density, and you're going to want to create a formula sheet, and you should put things like the conversion for Celsius to Fahrenheit and the other way around. But you should also put density. You should also put things like how do you find speed? Speed is distance divided by time, which will be in our next unit. So this formula sheet you're going to want to create is going to be used basically from now to the end of the semester and into semester 2. So you want to make sure it's really well done and that you're not losing it. The first thing you're going to do is put density as mass divided by volume, where the unit we're going to do is grams per cubic centimeter, where mass is in grams and volume is in milliliters. So we're going to want to convert to those units to make it work. And remember, a milliliter is defined as 1 centimeter times 1 centimeter times 1 centimeter, or 1 milliliter, again, is equal to 1 cubic centimeter. Very good test question. Guarantee it's on the test. So the volume of 1 centimeter or 1 cubic centimeter or 1 milliliter is this. And remember, there's 1,000 of them in 1,000 milliliters, or 1,000 cubic centimeters is the same as a liter. Let's take a quick look here.
Let's compare the density of these 4 solids and these 4 liquids. Cork, oak, ebony, a lead sinker, vegetable oil, water, carbon tetrachloride, and mercury, which I've already poured. Did you know doctors measure the density of urine to diagnose some diseases? I thought you'd like to know. Makes for a good party icebreaker. Okay, how about this one? Mechanics measure the density of the battery fluid to check the car's battery.
Okay, I want to look at this for just a second. This is mercury, which we cannot have in class. It's very dense. And then you can see a delineation where all the different things are actually separated out by density. That's why if you have a good salad, you usually need to shake it if it's like a vinaigrette, because it's separated out by density.
Here's the question. In what order do you think these solids will arrange themselves in the jar? Go ahead, guess, while I drop each one in.
So that's a lead sinker.
Lead.
That's floating on top of the mercury.
Oak. And cork. Okay, based on what you've just seen and heard,
so as you saw, look at that. There's the lead sinker right on top of the mercury. So it's less dense than mercury, but more dense than the liquid above it. And all the others actually went kind of at the breaking point to looking at that. This is what I'd also like you to put in on your formula sheet. And this is how we do the cheating measure of math. Anytime it's a 3-variable equation where one thing is multiplied together, and this by default, you have division if we work it out, we can use this to figure out our formulas. So this is called the density triangle. And this is like saying density is equal to mass divided by volume. Okay, well that's great. So if I were to say I wanted to find density, I would cover this up. And do you notice that the mass is on top of volume? And that's telling us that we divide, because remember, division bar is anything on top. Let's say I wanted to find volume. So I want to come up with that formula. Well, if I cover this up, I find out that volume is mass divided by density. And if I wanted to find mass, well, two variables right next to each other implies that it's multiplication. So if I wanted to find mass, that formula, that's equal to density times volume. So this is a really good triangle to put. And you'll also notice that in here, I put in my units. Mass is in grams. Volume is in either a milliliter or a cubic centimeter. And then density, therefore, is grams per milliliter or grams per cubic centimeter. So here are my units for density. And it's helpful to have that written in the formula. And you don't have to spend half your time trying to remember what are the three different formulas, because I can guarantee you on the test, I'm going to give you three problems. One where you have to find mass, one where you have to find density, and one where you have to find volume. It's just a given. So you can write down all three different formulas if that makes it easier for you. Go for it. I find, and most people do find, that this handy dandy little triangle, which we use a lot, is a great way to do it. So I would put this on your formula sheet. If you need to go back and have more time, then you can go back in the notes and do that. So if wood floats on water, it has to be less dense than the water, right? We just saw that. So wood floats on water, has a volume of 25 cubic centimeters and a mass of 20 grams. I could figure out that the wood is 20 grams because it's mass divided by volume divided by 25 cubic centimeters, and I'm left with 0.8 grams per cubic centimeter as its density. And as we define the density of water as 1, because we set that up when 1 milliliter is equal to 1 volume of water is 1 cubic centimeter, we define water as the density of 1. So wood being less than 1 is going to float. If it had a density like gold, which is more than 1, which is 19.3, that's going to sink, right? It's not going to be floated, or there's no buoyant force enough in water to make that float. Now there are other liquids that you could make it work, but not water. So this is where we're going to look at, here's a bunch of different densities, and this is grams per cubic centimeter. Air's density is 0.0013. Wood, that is oak, is 0.85. Water is a density of 1. Ice, because remember the Mickey Mouse molecule where it goes big oxygen, 2 hydrogen, big oxygen, 2 hydrogen, actually gets a little airspace and its density goes down. That's why your ice floats in your water glass. Ice floats because it's just slightly less dense than water. Aluminum 2.7, lead, gold, ethanol. So now you're going to actually use that table to answer these questions. Then you're going to go on and we're going to take a really quick look at this. So the interesting thing is, even though the metal on the boat should sink, if it's spread over a large enough area to displace that amount of water, we can actually make it float. So if we can get its density less than 1 gram per milliliter, if its density is greater than 1 gram per milliliter, it's going to sink. If it's less than 1 gram per milliliter, it's going to float. And that's why we don't want water to get into the hulls, because that airspace is what helps us stay. Concentration of salt in the Dead Sea is 31.5%. And get this, because of that, you will float. But also because of that, a lot of people, they still have to have lifeguards on duty, actually drown in the Dead Sea, because if you get flipped over on your stomach, you can't force yourself up to flip over. And so you have to be careful with that. You want to make sure you can always get your feet down and get yourself back up. There's a lot of salt because it's as the water evaporates and more salt comes into it, it just gets more and more dense. So let's take a quick look at this.
Hi, I'm Eric Trinidad, and we're here at the Dead Sea in Israel, where we're going to answer the question that we've all been wondering since biblical times. Will a 14-pound bowling ball float in the Dead Sea?
Do you think a 14-pound bowling ball float in the Dead Sea?
I'm gonna say no.
The Dead Sea has attracted visitors for thousands of years, and today it's a popular destination for tourists who come to cover themselves in therapeutic, mineral-rich mud. They also come for the novelty of floating in the water, because there's so much salt in it that many things become unusually buoyant.
Sally, do you think a 14-pound bowling ball will float in the Dead Sea?
Yeah, I think it's possible. I'm not really sure. I don't know. It could go either way.
About 31% of Dead Sea water is comprised of natural salt. This makes the Dead Sea denser than ordinary water by about 17 to 24%, depending on the data you find on the internet. This means that a 14-pound bowling ball could float in the Dead Sea, but not in a tub full of bathwater. or at the beaches of Israel along the Mediterranean, or in a swimming pool outside the old city of Jerusalem. Or even in the Sea of Galilee, where Christians believe Jesus walked on water.
Well, you got a little history here.
Has
But we're
anyone
really
ever
looking to see,
tried to do
will it
this
float
before?
in the Dead Sea?
Not as far as I know. Never with a body block.
It floats.
Totally floats.
So that means there's enough buoyant force because of that additional salt, the density, that it is more dense than the bowling ball, forcing it almost up to the top. All right, here are some nice density problems for you. Density is mass divided by volume. Here's your mass. Here is your volume. Do some division. Again, would the objects with the following densities float, sink, or remain suspended in water? Here is the hint. If water's density is 1, if it's greater than 1, it's going to sink. If it is less than 1, it's going to float. And if it's right at 1, really, really close, it's going to kind of hover. It's going to be called something called neutral buoyancy. So figure those out. You've got multiple attempts. Here's some more practice problems, some density problems. This is actually a old paperwork sheet that was 2 sheets in one, and I combined it into this one where I didn't make you look up the densities on another sheet to figure it out. So this is just some straight up practice. This is the only practice I'm going to give you with density, so make sure you're taking this seriously, and if you need to do this again or ask questions, this is where you do need to make sure you're understanding how to calculate density, because it is obviously on the test. And you are done.